that there are two cases of an ellipse. The first case here is the horizontal ellipse. Before we go over this case, let's have the parts of every ellipse. The first part that we have here is the center. The center is halfway between the two diameters of the ellipse. The second part that we have here is the major axis. The major axis is the longer diameter of an ellipse that connects the two vertices passing through the center. So this means that both of these two dots that we have at the end of the major axis are the vertices. So one is the vertex and the other is the other vertex. The plural for that is vertices. So pretty much vertex is the end point of the major axis. Now we also have another diameter which we call as the minor axis. This is the shorter diameter of an ellipse that connects the two co-vertices of an ellipse passing through the center. So this point right here is a co-vertex of an ellipse, and this point down here is also a co-vertex of an ellipse. The next part of an ellipse is focus. So these 2 points right here are the focus of the ellipse. The plural for focus is foci. This focus is always gonna lie along the major axis. Please remember that foci of an ellipse are two fixed points on its major axis such that the sum of the distance of any point on the ellipse from those 2 points is constant. So those are the basic parts of an ellipse. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis. So that means this runs from the center to the vertex, and we are going to represent this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, meaning this connects the center to one of the co-vertices. And this line segment from the center to the co-vertex is represented as letter B. Now, on the other hand, from the center to the focus is represented as letter C. Now, using these letters A and B, we can derive the equation of a horizontal ellipse. Now, using these lengths A and B, we can come up with an equation of a horizontal ellipse, and that is x squared over a squared plus y squared over b squared is equal to 1. Now, notice that our A is the longer value, because this is actually half of the major axis, which is the longer diameter. Now, notice that our A, which is the longer value, is the denominator of x squared. This means that if the denominator of x squared is bigger compared to that of the denominator of y squared, that means that we can come up with a horizontal ellipse. Now, we also remember that our A value, which is the semi-major axis, will always be greater than B, which is the semi-minor axis. That's always every time. And the equation that can be used to determine the length of C, that is from the center to the focus, is C squared equals A squared minus B squared. Now, let's look at the second case of an ellipse. For the second case of an ellipse, we pretty much have the same parts. The first part is the center. Again, this is halfway between the two diameters of an ellipse. We also have a major axis. This is the longer diameter of an ellipse that connects the two vertices passing through the center. Now, please notice that we call this as a vertical ellipse because the major axis is the vertical line segment. We also have the parts which we call as the vertex. There are two of them. We call them as the two vertices. These are the two endpoints of the major axis. We also have a minor axis that is the shorter diameter of an ellipse that passes through the center and that connects the two co-vertices. And again, on this, along this minor axis, we have the co-vertices or the co-vertex if it's singular. These are the endpoints of the minor axis. Now, we also have another part which we call as focus. So these 2 points right here are our foci. So pretty much these are the parts of an ellipse. So it doesn't really matter if it's a vertical ellipse or a horizontal ellipse. The parts would still be the same. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis, which means this connects the center to the vertex. And we are going to label this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, which means this connects the center to the co-vertex or one of the co-vertices. And we're going to label this as our B. Now, we also remember that the distance from the center to the focus is represented as letter C. Now, using these lengths A and B, we can therefore say that our equation for a vertical ellipse is x squared over b squared plus y squared over a squared is equal to 1. Now, notice that our a squared is under the y squared. This means that if the value under or if the denominator under the y squared is bigger than the denominator under the x squared, we are able to get a vertical ellipse. And we also remember that again, our A is always greater than B. Now to determine the length of C, we are going to use the equation C squared equals A squared minus B squared. So these are the parts of an ellipse and these are the two cases of an ellipse. If you find this video helpful, hit like and subscribe for more math videos. See ya!